Applications of artificial intelligence in live-action role-playing games. Or, can AI conquer LARP? Hello, I'm Christoph Salge from the University of Hertfordshire, and today I want to talk to you about applications of artificial intelligence in live-action role-playing games, or LARP for short. I want to convince you that LARP offers unique opportunities and very interesting challenges for AI, and specifically for game AI or AI in games. And to that end, I'm going to first give you a short definition of what LARP is or how we can think about it, then talk about some specific properties of LARP that make it so well suited for AI applications, and then run you through some evocative examples. At this stage, I also like to specifically thank Ben Crossley and Jonathan Henderson, two LARP practitioners and organizers we've specifically interviewed to check that the examples we're talking about make sense. So, what exactly is LARP? Well, the term itself stands for live action role playing, or sometimes also live role playing. The terms are used interchangeably. And it's a form of play in which you pretend to be somebody and act out that character in the physical world. Usually it's an embodied experience in which at least some people are acting out their own characters. And contrary to a lot of other forms of play, it often veers away from being focused completely on winning the game towards having an interesting, immersive, or evocative experience. And while the most common and probably commercially most successful form of LARP is fantasy LARP at large festivals, where you run around and pretend to be a wizard or an orc and you hit each other with swords like this, it's grown into a big field these days, and in Germany alone I think there are over 700-800 events every year, and that has led to a huge degree of diversity in various entertainment-based LARPs, and there's also been a massive growth in other forms of live action role playing that cover a very diverse range of fields. It's also been a bigger hobby sector now with things like murder mystery parties, which in a way are live action role play like events. And so it's very hard nowadays to exactly define what a LARP is, as it is hard to define what a game is. One way to think about this is to look at related concepts. So, for example, if you are familiar with tabletop games, you can imagine LARP as a tabletop game with added physical play where you have to act out your character. If you want to come at it from improvisational theater, you can imagine you're improvising a play, but you have some gamified rules. So every time a conflict arises, there's a way to solve whose idea of how the story progresses will prevail. And you usually add also goals to the characters. And if you're familiar with reenactment, where people play out battles of the past, you can imagine LARP as a historical enactment where the outcome is not clear and there's some gamified rules to educate who will win. And this isn't just a way to understand what LARP is, it's also a good way to see where live action role playing comes from. It has like different historical origins. A lot of the community has grown from these different vectors into the LARP field, and as a consequence, nowadays LARPs also differ in what they focus on. So, for example, fantasy LARP or festival fantasy LARP sees itself more as a successor to tabletop roleplay, while things like Nordic LARP and theater LARP are probably closer to their improvisational theater roots, where they focus more on interpersonal relationships and playing out your characters. In either case, today we're going to be focusing mostly on the more classical adventure festival LARP style, but a lot of the thoughts we're going to have are applicable to other forms of LARP. Now that we know what LARP is, we can ask ourselves again, how does AI fit into this? Game AI basically offers us two directions of attack. One, gameplay AI. And while I'm looking forward to having a LARP experience with an ad hoc, socially capable, fully embodied AI, I'm not going to hold my breath for that to happen anytime soon. It is so worthwhile to keep that in the back of our mind whenever we talk about general gameplay. which often is seen as somewhere laying on a scale between GVG-AI and StarCraft, while in truth should incorporate a much wider range of gameplay options. The other more fruitful area of attack is all those methods in game AI that are used to enhance, design, improve games. Things like believable NPC generation, procedural content generation, player modeling, and the like. And this is where we'll be focusing on. When we're now looking at the properties of LARP, we see that one big difference to traditional roleplay is its decomposition. A LARP is usually organized by a group of people, while traditional tabletop gaming has one DM or game master that incorporates all of these facets together. So things like event generation, quest generation, the simulation of the world the players are situated in, the provision of information, and also arbitrating rules is all done by the same person to a singular narrative interface, i.e. talking to that person at the other end of the table. The world state of the game that is fictional resides in the game master's mind and is communicated to the players upon their request. And since it's all done through one person, things like cohesion and interfaces are neatly sorted out. In contrast, in LARP, several problems arise from this structure. So the interface between the virtual and the real is done through many people and often provides a bottleneck. So even while bigger games such as the Empire LARP in England have actual data backends that store additional information about the player, accessing this requires people to find a game organizer and then have them enter data into this online database. Cohesion is another aspect where in LARP several things might happen at the same time. People are given different information and that information clashes with each other. And also often certain elements and functions are channeled through a singular person, like a plot ref. A singular plot ref might be responsible for the storyline as it unfolds, or a singular person might be responsible for simulating certain aspects of the world, such as international politics. And the larger the game then grows, the more these issues become bottlenecks, and that often results in a design to reduce player empowerment. So games are set up in a way that players can do stuff, but they can't really affect too many things at once or too many things in a interactive fashion, but only big changes are being processed, or when people actually interact with the important organizers are these changes reduced. And I think that AI can actually, find great challenges in these different elements and also help us overcome some of them. So the interface between the virtual and the real is an interesting problem for human-computer interaction and human-robot interaction, and offers some really interesting elements there. Cohesion, again, is a topic that we'll have to tackle with AI at some point. How do you deal with separate conflicting world representations and how can you integrate them? Also, scalability and bottlenecks is a very interesting issue because AI solutions are often hard to obtain, but once we find them, they can be scaled up quite easily. And all of this can then allow us to design games that not only increase the player empowerment, but allow for options for player empowerment that are without AI or without technology not even possible. So let's look at some of these elements in a bit more detail. One interesting problem is quest generation. We've already discussed that quest generation is often done by a very limited amount of people, so if you have more and more players, the amount of quests generated for the game might stay the same and become thereby sparser on a per-player basis. If we do want to automatically generate quests, this provides several interesting challenges. There are already quest generation frameworks out there in the game AI literature, but they do generate quests for computer games and often rely on the ability to conjure up things like artifacts, quest givers, locations out of thin air, which in a LARP you cannot simply do with a computer. And also, they often require some checking for success at the end. In contrast, For LARP, a system that might generate story hooks might be more feasible. And one way to approach this would be to look at these various ideas that were used to generate murder mysteries. There's been several works where people generated information games where initial conditions were put out, then simulations were run that would lead to a murder or some kind of interesting events. And then the player would investigate the aftermath of these, trying to reconstruct what actually happened. For LARP, we could go a similar route, distribute certain conditions, like somebody might want to marry off their niece, and somebody might want to marry off their nephew, or somebody might want to spy on somebody, and then simulate what could potentially happen, but rather than have the simulation play out and reconstructed by the player, we'll just pick that set of story hooks based on some database information that leads to the most interesting outcome, and then provide that to the players in the field at the beginning of their briefing, and then maybe provide a little bit of redundancy and see how these various story hooks of, one maybe spying on another, two other people maybe having a story hook that makes them engage in some shady dealings, and then just watch how these things play out, with success and failure purely being determined by what the players then make out of it. And this would allow us to create like a richer tapestry of the world. And if we had a player database with like player characteristics, we could even tailor those story hooks to the particular player population, creating a more dense and more rich experience. Another issue is the generation of information about the world. Often the world is drawn in broad strokes by the game organizers, but the detail is often lacking and players fill that in as they go along. But this sparsity often prohibits a certain playful discovery of the world, as that information is simply not there, and the organizers usually lack the resources to generate it. That, for example, makes some form of scholarly gameplay impossible, where wizards or scholars might want to dig through several big books to find some kind of hidden clue, but it's impossible to actually produce meaningful books. We could rely here on procedural content generation techniques to fill in some of these gaps. Imagine, for example, you take a system that can write travel diaries, you feed it with some data about the world that you already have generated, and create several travel diaries in which you can then hide some important bits of information about the world that's relevant to the players. You can then print out these books, put them in a library, and allow for some more scholarly inclined players to actually sit down and work their way through several books, hunting for that one hidden clue. There's actually some great related work out there in forms of the game Bad News, created by Ben Samuel and colleagues, where procedural content generation is used to generate a whole town of people, and the player then embodies a mortuary's assistant that has to deliver bad news to one person in this town, but to eventually get there has to first engage with a variety of other people. And this is only possible because all these people and their relationships have actually been generated by an algorithm, so the actor portraying them can access a database and can fall back on this rich world and this meaningfully constructed narrative generated by a computer. And in that similar vein, there are many opportunities for procedural content generation to create like a rich tapestry that can serve as a backdrop for more engaging and more dense roleplay. The world simulation in LARP decomposes into three elements. Part of the world is simulated by reality. You eat food and you feel full, just like in real life. Another part is simulated by other players. You interact with them, they play also a role, and you might have an emergent narrative that never touches the fictional world state in any way. The third element, where your actions actually interact with the larger shared fictitious world state, is a bit more complicated. Here, computer games have made huge strides forward, like flight simulators provide flight physics and the like, and in LARP, this is often done by people, and here's the bottleneck. We could overcome this. Things like diplomacy, global trade systems could be simulated by multi-agent simulations or some other form of AI, but there are also some more quirky examples we could realize. Imagine ritual magic, often performed by people in a circle. A DM, which is a bottleneck again, has to evaluate it. It's often a different DM. It's not very responsive. It's also often unclear what exactly influences what you're doing. Now instead, imagine we'll take some kind of neural network and we design ritual magic around that. So the players might wear a transponder, they have to dance certain runes, which then trigger certain reliable effects. Those runes might even have to be discovered first. Suddenly magic becomes a system that can be explored, can be tried out at any time. It can actually have people trained to be better at it. And then, dancing certain runes in a combination could evoke certain magical effects, and that would create a really nice gameplay that allows people to dig into magic and really kind of look at it, rather than just writing down what they want to happen and then hoping that the DMs might grant this to them or not. And in a similar vein, there's a lot of systems we could again design that play with this kind of interface. Interfaces between the fictitious world and the real world are actually another really interesting and challenging application. There's related work by Sakura et al. On AI wearables that make part of that world state visible, but along the same lines we could also imagine designing much more elaborate interfaces moderated by an AI, possibly a conversational agent. Our interviewees were already very excited about an AI that could just explain the rules to people or just provide simple information about their game worlds. Often NPCs have to be sent out, briefed, so they can inform the players about what's going on. But this again requires a lot of manpower, is often a bottleneck. Imagine everybody has their own talking sword or talking book that could just tell them a few important bits, or even could react contextually to some of the things that happen in the world, such as, ooh, I sense that a lot of people died here, or have a certain conversation at a certain time. Well, I'm getting very excited about these topics, and there's a few more examples that I have and that you can find in the paper, or you can just find me and discuss with me. I will have to come to an end soon, but there's one more point I wanted to point out. So people who are playing LARPs, they're used to things not working out, and they're also used to the idea that they themselves are part of the game world of others. So there is a sense that you're not just there to consume the game, but that you're also part of facilitating this game. And so people are usually quite good at helping things out, papering over minor flaws. They're willing to extrapolate and improvise from minor clues, and all of this will allow us to even test out slightly faulty AI approaches, or sometimes even the problems with the AI can become part of the gameplay. I mean, my 5-minute LARP idea for today is, imagine you're locked in a room and the only way to get out is to convince Alexa to let you out. Alexa, open pod bay door 5.
I am afraid I can't let you do that.
This brings us to the end of our journey today. I hope I could convince you that there is a role for AI to play in live-action role-playing games, or at least interest you in the topic a little bit. If you are, I recommend you have a closer look at the papers we wrote, or find me or one of our co-authors for a discussion about future topics, future work, or possible collaborations. At this stage, I'd like to thank all of my co-authors, and specifically Schloss Dagstuhl, where we had the opportunity to develop this topic. And I'd also like to thank Jonathan Henderson and Ben Crossley for their feedback and help to hash out the examples. And that is all for me. I'll hope you have an enjoyable COG, and I do hope that there is a better future for AI and LARP.